Assalamualaikum warahmatullahi wabarakatuh. Hi, hello. My name is Chan Uswatun Hasanah. I am the author of the paper. This paper titled Implementation of Data Augmentation Using Convolutional Neural Network for Batik Classification. So let's get started. Batik is one of Indonesia's cultural heritage that has been recognized by United Nations Educational, Scientific, and Cultural Organization (UNESCO) so that increase the popularity of batik in the world. Therefore, we as Indonesians are responsible for preserving batik. Various kinds of batik motif continue to be developed. Until now, Indonesia already has more than 5,000 batik motifs, such as parang, kawung, and pataruman. However, it is inversely proportional to the lack of knowledge of the younger generation about batik motifs. So, the development of a batik classification methods is needed. Research on batik classification has been done before using various methods. Research by Minarno generated an accuracy of 82% by classifying 300 batik images into 50 classes. Researchers used the multi-texton histogram methods as feature extraction and k-nearest neighbor as the classifier. Research by Karima and Harjoko classified batik using KNN as well as feature extraction methods, gray level co-occurrence matrix, and speed up robust features towards 371 batik images. The resulting accuracy is 95.47%. CLCM was also used as feature extraction on 698 batik images using the linear support vector machine, which generated an accuracy of 70.34%. Most of the classification methods that have been done before feature extraction is separated from the classifier and weight is difficult to be moved to identify batik motifs. The method that is introduced in this paper is deep learning. Convolutional neural network (CNN) is a variation of the deep learning method used as a proposed method to solve batik classification problems. CNN is known to solve problems related to image processing. CNN has ability to detect and recognize objects in an image, also can outperform traditional methods in computer vision and pattern recognition tasks, such as object detection, classification, image segmentation, and text recognition. CNN can also automatically learn the feature in the image without we need to decide what feature is taken from the image. Tristanto classified 967 batik images, 13 classes, using CNN, which consisted of 4 convolutional layers, resulted in an accuracy of 56%. Handayani classified batik on 698 images, 7 classes, using CNN, which consists of 3 convolutional layers, resulted in an accuracy of 63.73%, lower than SVM linear and SVM radial basis function. Based on researchers 5 and 6 show that the CNN model that is self-made has not been able to obtain high accuracy in batik classification. The pre-trained model is a CNN model that is resulted from ImageNet competition and available on the internet. The pre-trained model that have been used to classify batik are InchRes and VGG. Wicaksono classified 7,112 batik images, 11 classes, using each race resulted in an accuracy of 70.84%. InRes is a combination between GoogleNet and residual network. Arsa and Susila classified batik using VGG16 and random forest on 300 batik images with an accuracy of 97.58%. Gultom classified 2092 batik images, 5 classes, using VGG16. The VGG16 achieved an average accuracy of 89%. Agastya and Setyanto classified 900 batik images into 5 classes using VGG19, resulted in an accuracy of 89.3%. Based on those researches, it can be concluded that using a pre-trained model generated higher accuracy than using the CNN model that itself made. So we classify batik using the VGG16 pre-trained model, which has been proven obtained high accuracy. The batik classification model must be able to classify batik images that have various conditions because batik images can come from the internet or self-capture. The batik image looks mixed with other objects, and the batik image has a different brightness in each part. So image variations is the main challenge in this research. Varied image will allow CNN to capture common features from the dataset. In order to increase the image variation, we propose a data augmentation method. Data augmentation has the ability to increase image variation by manipulating it in several ways, such as flipping, resizing, random cropping, and color translating. Tristanto performed data augmentation, rotation, share mapping, zoom, horizontal flip, translating on 967 batik images using CNN. The accuracy obtained was 56%. Agastya and Setyanto performed a data augmentation scale with a value of 1.2 using CNN VGG 19 on 900 batik images, was obtained an accuracy of 88%. The data augmentation used is still limited. In this research, we propose to use 8 data augmentations using CNN to classify batik. The purpose of this research is to determine the effect of data augmentation implementation on the accuracy value of batik classification using CNN. Batik dataset. The data used to construct the dataset is a batik image that is downloaded from Google Image. The dataset consists of 5 types of batik or class, namely ceplok, kawung, lereng, nitik, and parang, each of which consists of 100 pictures per class or 500 images for all classes. After the data is collected, each group of images is divided into training data and testing data with a ratio of 80-20. Each class is divided into 80 images for training data and 20 images for testing data. We use the VGG16 pre-trained model to classify batik. The model is trained to use the batik dataset, so it can classify 5 types of batik, namely ceplok, kawung, lereng, nitik, and parang. VGG16 consists of 16 weak layers with 13 convolutional layers and 3 fully connected layers. When training VGG16, we use the fine-tuning method. Fine-tuning is applied to deep learning model that has been previously trained on a different dataset. We use fine-tuning by retraining some convolutional layers or trainable layers. We train on a block 5 convolutional layer. In the fully connected layer, we design to match the classification that we do. In the output section, we divide it into 5 classes according to the number of classes that we have. We implement 8 data augmentation. Those are rotation, zoom, share, brightness, width and height shift, random erasing, and channel shift. In Table 1, we determine the value for each data augmentation. Data augmentation is a technique used to artificially increase the amount of training data by making more variations in the image to generate new image. We implement 8 data augmentations in the training data, then we train it using VGG16 with fine-tuning method. The accuracy generated by each data augmentation is shown in Table 2. Based on Table 2, we select 8 data augmentations into 2 groups. Those are Group 1 and Group 2. Group 1 consists of 4 data augmentations with the highest accuracy. Those are with shift, zoom, rotation, and shear. Group 2 consists of 4 data augmentations with the lowest accuracy. Those are height shift, random erasing, brightness, and channel shift. The accuracy value has increased or decreased after using data augmentation. The highest accuracy value is when using width shift and zoom of data augmentation with an increase of 2.09%. The accuracy value decreased by 12.5% when using the channel shift of data augmentation. We retrain the batik dataset by combining data augmentation in Group 1, Group 2, and Group 1 plus 2, or combining Group 1 and 2. The accuracy results are shown in Table 3. The accuracy value in Group 1 is higher than Group 2, indicating that the data augmentation selection can increase the accuracy value. The accuracy value increased by 3.13% from 95.83% to 98.96%. The accuracy value in Group 1 is higher than Group 1 plus 2, indicating that the implementation of more data augmentation does not mean that the result of accuracy is better, but we must use data augmentation as needed. Comparison of accuracy values against previous researches on batik classification is shown in Table 4. We managed to get a high accuracy value of 98.96% despite using a smaller dataset than the dataset on number 3 and 11 until 14, and shows that CNN VGG16 can do batik classification well. In conclusion, the accuracy value of batik classification using the VGG16 pre-trained model can be improved by implementing data augmentation. Based on the experiment that have been done, we get the result that data augmentation increases the accuracy of 3.13% from 95.83% to 98.96% by combining data augmentation through a selection process. For future work, this research is successful in showing the accuracy value of the implementation of 8 data augmentation on the batik dataset. In total, 500 images for 5 classes. In further research, experiment can be done to see how the value of classification accuracy using data augmentation on batik dataset with more or less numbers or on different datasets. In addition, the research can also use data augmentation with various value, so it can be found which is the value of data augmentation that generates the highest accuracy. Thank you for listening. May all those we have shared be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.